All right, part C, we're given some particular solution. We don't need to find it for part C, but we want to figure out if f, this particular solution, has a relative minimum, relative maximum, or neither at x equals 2, and we want to justify. So we're going to use the second derivative test to check. We know the first derivative is, so dy dx is 2x minus y. We just found the second derivative in part B. If you want to see how we got there, go back to that video. And that was 2 minus 2x plus y. And the way we know if we have one of these is the following. If the first derivative equals 0 and the second derivative is positive, we'll have a case like this and get a minimum. If the first derivative is 0 and the second derivative is negative, we'll get a case like this and we'll get a maximum. And if the first derivative isn't 0, we won't have a maximum or a minimum. If the second derivative isn't positive or negative, if it's equal to 0, or if this is undefined, we'd have to do something different to figure it out. But let's look and see what happens. So the first thing I'm going to do is check to see if this equals 0. So dy dx evaluated at this point, 2, 3, is going to equal 2 times 2 minus 3, which is of course 1. It can't have any extreme value there because this is not a critical point. It's increasing at that value, or increasing around there. So we know that it has neither, since dy dx evaluated at the point 2, 3 does not equal 0. And that's it. If it did equal 0, we'd plug 2 and 3 into here and see what happened. But since it doesn't equal 0, we have neither.